let's finish up this example here. So when we're working this, I accidentally moved this over and changed the trig function, and we don't want to do that. So this is actually cosine, this is cosine, so cosine, cosine, and then we end it, and what we were doing was trying to get this r by itself to get our polar equations. This ends up giving me r equal to 2 over sine theta minus 3 cosine theta. So this would be your polar equation of the Cartesian equation of 3x plus 2. So you can see on this one, it's a little bit more moving and shuffling than we did in the previous one. Now I want to finish up this lecture and I want to do one more example with you. So here's one, and it says convert the polar equation r equals 2 secant theta to a rectangular equation. So now we're going to go the reverse of that. And so what I'm going to do is I'm trying to get, let me get the trig function and the r back together and see if we can make some kind of assimilation and maybe use some of these formulas that we've already picked up. So I have r equal to 2 secant theta. And so what I want to do is I want to go ahead and change secant theta into it's either sine or cosine. So this would be r equal to 2 over cosine theta. So to get rid of division by cosine, I'm going to multiply by cosine. So I get 2 equal to r cosine theta, which is interesting because you'll notice here r cosine theta is equal to x. So I could just say this whole piece here is x equals 2. And so r equals 2 secant theta, that would be your polar equation. X equals 2 would be your rectangular equation. So as you're working through 10.3, you're going to be going from polar to rectangular, not only coordinates, but also equations. And some things to remember is a nice little conversion formulas down here at the bottom of the lecture. So if you have any remaining questions for 10.3, feel free to contact me and I can help you work through some of those.